Hi, this is Brendan with Cusack Prep, and in this video we're going to be discussing composite functions with variables instead of with numbers. So the big difference with variables and numbers is you're usually asked to expand or express or which one is equivalent to, and you're not actually looking for a number as your final answer, but you're actually looking for your final answer to still have whatever variable is in it. So for example, let's say we had these two functions, f of x equals 2x minus 7, and g of x equals x squared minus 4x plus 2. Well, if I wanted you to figure out what f of g of x was equal to, what we have to do is similar to what we did in the last video, where we're going to work from the inside out. So I need to figure out what g of x is. Well, unlike the last video, I don't have a number. I'm not figuring out g of 1 or g of negative 2 or anything like that. So what I have to do is think of g of x as being x squared minus 4x plus 2. So my initial step is actually just to replace g of x, this whole thing, with what's on the right side. When I do that, this is going to become f of x squared minus 4x plus 2. And then we say, okay, well, what do we do with that? Well, notice now how f of x has become f of this whole thing. Well, in previous examples, what we did is we took whatever was in the parentheses and we substituted it in for x. So in the f of x function, I have 2x minus 7. I need to take that x and I need to replace it with all of this. I'm going to change the colors to help you see that. So x squared minus 4x plus 2. And then minus 7. So notice if I compare this to this equation up here, my 2 has stayed the same, my minus 7 has stayed the same, but what I've changed is this x value has been expanded to become this whole thing. Now we can go ahead and simplify this, and the SAT will probably require you to do that. And so what I'm going to do to simplify is I'm going to distribute the 2. So distributing the 2 to each of these terms, I would have 2x squared minus 8x plus 4 minus 7, which would then be 2x squared minus 8x. Plus 4 and minus 7 is going to give you a minus 3. And that's pretty much as far as you could go with this, and that's going to be your final answer. So key things that we did, f of g of x, we first replaced g of x with what was on the right side of the equation. We then had f of this whole function, and so we replaced x in the f of x equation with all of this. Let's go ahead and take a look at the next problem. So here we have g of x and we have h of x. So if we wanted to figure out what g of h of x was equal to, well, think about what we did last time. So the first thing we did, we always work from the inside out. So I need to replace this h of x with what's on the right side here. So step 1 is instead of h of x, writing g of x minus 7. Now when I have g of x minus 7, well, the g of x equation was x squared plus 2x minus 4. And what I need to do is replace x with x minus 7 and do so in parentheses. So instead of x squared, I now have x minus 7 squared. Instead of plus 2x, I now have plus 2 times parentheses x minus 7. And then I have minus 4. Now to simplify this out, do not say that x minus 7 squared is x squared minus 49. It is not. X minus 7 squared is x minus 7 times x minus 7. This 2 can be distributed to give us plus 2x minus 14 and then minus 4. Now x minus 7 times x minus 7 needs to be FOILed out. and then plus 2x, minus 14 minus 4. And then we need to combine all the like terms. So we're going to have x squared minus 7x is minus 14x, plus 2x is minus 12x, 49 minus 14 is 35, minus 4 is 31. So we would have x squared minus 12x plus 35. Now, oddly enough, and I didn't do this on purpose, I do believe this can be factored, because you could factor it into x minus 7 times x minus 5. You may have to pick either of those two answers for the SAT. I don't really know. It could be one, it could be the other. It just really depends. Okay. Thank you for watching. That video explained how you deal with composite functions which have variables in them.